So what does it really mean for a machine to see? And I'm not just talking about, recording a bunch of pixels. I mean, to truly understand what it's looking at. That simple but kind of profound question is what we're going to dig into today.
There's this great quote from a computer vision researcher, Steve Seitz, that I think just nails it. He said, "Every picture tells a story." And that's so true, right? A picture isn't just a grid of data. It's a whole narrative packed into a single frame. It's a snapshot of a moment filled with context, people, things, actions. It's trying to tell you something.
But that's the million-dollar question, isn't it? How does a computer go from seeing just a collection of colored dots to actually understanding the story behind them? Well, it turns out there's a whole field of AI that's completely dedicated to answering that exact question. And that field, it's called computer vision. It is all about building machines that can see, that can interpret an image, and basically unlock all the knowledge and meaning that's hidden inside.
So yeah, the key words here, the ones you really want to latch onto are interpret and understand. See, we're not just shuffling pixels around. We're trying to teach a machine to get a high-level, almost human-like understanding from what it sees, kind of like how our own brains work.
And really, the end game here is to copy and automate what our own eyes and brains do without us even thinking about it. I mean, just think about it for a second. When you look at a scene, your brain instantly identifies objects, it recognizes faces, it senses movement. That's the magic we want machines to be able to pull off.
Okay, so this is a super common point of confusion, but it's really, really important to get this straight. There's a huge difference between computer vision and something called image processing. Let's break that down right now.
All right, here's the simplest way to think about it. Image processing is image in, image out. Think about putting a filter on a photo on your phone. You start with a picture, you end with a modified picture. It's all about manipulation. But computer vision? That's image in, meaning out. What comes out isn't another picture at all. It's knowledge. It's an interpretation. So one just changes the picture, but the other one actually understands it. Big difference.
So the big question is, how do we actually do this? How does a computer go from a flat, static image to, genuine understanding? Well, believe it or not, the whole thing can be broken down into a pretty straightforward 3-step recipe.
And the whole idea here is to mimic our own brains, right? Think about it. You don't look at a cat and analyze every single pixel one by one. No way. You recognize patterns, the pointy ears, the whiskers, the tail. That's it. And computer vision algorithms, they're built on that exact same idea. It's all about pattern recognition.
So here are those 3 basic steps. First up, the machine has to acquire an image. Could be a photo, a frame from a video, doesn't matter. Step 2 is processing. This is the big one. This is where it analyzes just massive, massive amounts of data that's already been labeled, all to find those patterns. This is where all the learning happens. And then finally, step 3, understanding. The machine takes what it learned, those patterns, and uses them to figure out what's in a new picture.
Okay, so that's all a little abstract, right? That's the theory. Let's make this way more concrete with a super simple example. Let's say we want to teach a computer to know its vegetables.
All right, so this brings us right back to step 2, processing. For a computer to learn the pattern of what a vegetable looks like, it needs a mind-boggling amount of data. I mean, we are talking hundreds of thousands, maybe even millions of pictures. And each one has to be labeled by a human first. Someone has to say, this is a carrot, that's broccoli, that's a tomato, over and over again.
Now, as the computer chews through all of these labeled images, it's not just memorizing them. That's not what's happening. Instead, it's hunting for the common patterns, the shared features across all those different photos of vegetables. And from all that analysis, it starts to build its own internal, sort of conceptual model of what vegetable means. And then here comes the payoff. Step 3, understanding. Now you can show the computer a brand new picture, something it has never ever seen before. And because of that model it built, it can look at it and confidently say, yep, that's a vegetable. It has actually learned to see.
But identifying a vegetable, that's really just the beginning. It's like chapter 1. So let's bring this all the way back to that original idea we started with. Because the true goal of computer vision, it is so much more ambitious than just naming objects. See, it's not just about being able to stick a label on a car or a person. The real goal, the holy grail, is to understand the entire scene, to answer the bigger questions. Who is in the picture? What things are there? And, the big one, what is actually happening? It's all about pulling that complete story out of the image. And that leaves us with a pretty fascinating thought to end on. I mean, from self-driving cars trying to figure out a busy street to medical AI analyzing X-rays, this tech is already changing our world. So as we get better and better at teaching machines to see, the real question isn't just if they can see, but what new insights, what new narratives, what totally new stories will they help us discover about our world and about ourselves? It's a lot to think about.